Hello everyone, welcome to today's video. Today we discuss about set pressure of safety relief device. There are different standards like ASME, API 520 available which provide information about set pressure of safety devices. But in my view, many times the concept is misunderstood or practical situation may different. So I decided to speak on this topic. But before that, I would like to request you, please like, share this channel and video which give us moral support, as well as people from same community will get benefited with shared information. We'll go through some important definitions. Maximum operating pressure. This is the maximum value of pressure expected during normal operating of the vessel. Design pressure. Design pressure for vessel is taken by adding a suitable margin to the maximum possible pressure during normal operation. This design pressure value is used to determine the minimum thickness for all vessel elements by applying vessel design rule to the design pressure. Design pressure is less than or equal to maximum allowable working pressure. When MAWP value for fabricated value is not available, design pressure value When MAWP value for fabricated value is not available, design pressure value should be used as a conservative replacement for MAWP. Maximum allowable working pressure. The maximum allowable working pressure is the highest pressure that the vessel can withstand based on actual nominal vessel thickness, excluding the allowance provided for corrosion and loading other than pressure. MAWP has to be at least equal to design pressure. MAWP is commonly calculated for a fabricated vessel. During fabrication, availability of material and thickness of material used usually leads to a vessel exceed the minimum requirement imposed by design pressure. For such a vessel, the MAWP is greater than design pressure. What it means, suppose I have to design a pressure vessel which can withstand for 10 kg per centimeter square pressure. It is my requirement. Now fabricator calculate the required thickness of metal sheet which can be used for the design of pressure vessel which can stand for 10 kg per centimeter square pressure. Suppose it is 4 mm thickness metal sheet required as per calculation, but in market standards available metal sheet of thickness 3 mm or 5 mm. Then he will use 5 mm metal sheet for fabrication of pressure vessel. So in this case, MAWP is greater than design pressure. For a vessel which only meet the minimum requirement imposed by design pressure, MAWP is equal to design pressure. Set pressure. Set pressure of relieving device on a pressure vessel is the pressure when the relieving device just start to open. Pressure accumulation. Maximum allowable accumulated pressure is specified for a vessel protected by pressure relief device. It is the maximum allowable pressure during discharge from the relieving device. This pressure is commonly expressed as a percentage of maximum allowable working pressure. This percentage is determined by the governing case for opening of relief valve protecting the vessel. For instance, vessel protected for fire case has a maximum allowable accumulated pressure which is 121% of MAWP. What we understand from this definition? First, MAWP either equal or more than design pressure. Second, design pressure can be considered as a base for set pressure of safety valve or RD when MAWP not known. But sometimes the situation is different, like design pressure can be more than MAWP. How it's so? Let's get understand. Basically, welding joint efficiency is one of the important factor for calculation of metal sheet required thickness for pressure vessel design at intended pressure. And by the time welding joint efficiency get reduces due to the age of vessel, corrosion, as well as if you see the handbook from ASME, you will find that welding joint efficiency considered in between 0.65 to 1. 1 is considered for radiographic welding, and also this joint efficiency also depends on operator skill. As welding joint efficiency reduces, MAWP of vessel also reduces. So in my view, it is always safe to set a pressure of your safety relief devices should be less than MAWP at least by 10%. And if two devices are present, one should be set at 5% of MAWP, basically safety valve, and other, that is secondary device, should be set at 10% of MAWP. Basically, it is safety valve or RD. What is your thinking? Please mention in comment. Let's consider two cases. First, pressure vessel with safety relief device set at 100 kg per centimeter square in fire condition, and pressure vessel with safety relief device set at 100 kg per centimeter square in non-fire condition. In both conditions, safety valve open at 100 kg per centimeter square, but in case of an fire condition, full lift point would happen at 121 kg per centimeter square, and that will be at 1110 kg per centimeter square for non-fire condition. Basically want to say that concept of 1110%, 116% and 1 to 1% of MAWP comes from old pressure relief valve design, which require 10% overpressure above set pressure of PRV. Otherwise, we may face with repeated opening and closing leading to PSV to chatter. Another documented reference organization Spirix shared in description box. We see some important definition and final conclusion from it. First, maximum allowable accumulation pressure. It is the maximum pressure the system is allowed to reach in accordance with specification of design standard of system. Set pressure, the pressure at which safety valves start to lift. Relieving pressure. It is the pressure at which full capacity of safety valve is achieved. It is the sum of set pressure and overpressure. Overpressure. The overpressure is the percentage of the set pressure at which the safety valve is designed to operate. There are two basic concepts for set pressure of safety valve as follows. First, set pressure low enough that relieving pressure should not be more than MAWP in any case. And second, the set pressure must be high enough to ensure that there is sufficient margin above normal working pressure to allow the safety valve to close. However, this set pressure must never be greater than maximum allowable working pressure. So let's see two cases. First one, the percentage of overpressure of the safety valve is less than or equal to percentage of MAAP, that is maximum allowable accumulation pressure of the system. This means that the set pressure can be made equal to MAWP, that is maximum allowable working pressure, as the relieving pressure will always less than actual maximum allowable accumulation pressure. What it means? Let's see. Suppose a pressure vessel having MAWP 20 bar and set pressure of safety valve is 20 bar. Overpressure is 5% of MAWP, which means equal to it is 1 bar, and maximum allowable accumulation pressure 10% of MAWP means it is 2 bar. In this case, relieving pressure is equal to set pressure plus 5% of overpressure, that is 21 bar, which is less than maximum allowable accumulation pressure, that is 22 bar. So the design is acceptable. Here, please make a note that it is not acceptable that increasing MAWP in compare with overpressure and rises set pressure above MAWP of vessel in any case. Second case, the percentage overpressure of safety valve is greater than percentage of maximum allowable accumulation pressure of the system. In this case, making the set pressure equal to MAWP will means that the relieving pressure would be greater than MAAP, that is maximum allowable accumulation pressure, so that the set pressure must be lower than MAWP. Let's see what is it. Suppose a pressure vessel having MAWP 20 bar and set pressure of safety valve is 20 bar. Overpressure is 25% of MAWP, that is a 5 bar, and maximum allowable accumulation pressure 10% of MAWP, that is a 2 bar. In this case, relieving pressure is equal to set pressure plus 25% of overpressure, that is 20 plus 5, that is 25 bar, which is greater than maximum allowable accumulation pressure, that is a 22 bar. So the design is not allowed as it is not safe. Which by simple mean that set pressure of relieving devices should always be less than maximum allowable working pressure at least by 10%, considering safer side of vessel and relieving devices. Please comment if I am missing anything or you have a different opinion on this topic, which will also increase the knowledge of people from same community. तो मिलते हैं हमारे अगले वीडियो में, तब तक के लिए मैं रोहित साइनिंग ऑफ, बाय बाय।